All right. On to the lesson, lesson 6, trapezoids and kites. Not a super long lesson. Yes, ma'am. Yeah. Not a super long lesson. Should have a good chunk of time to work on today. But they're the very last two shapes that we'll do. The plan is we will review on Wednesday. And then the final test will be on Thursday. So you guys can have a long 3-day break and you don't have to worry too much about remembering stuff until you get back. Oops. So lesson 6, trapezoids and kites. You're going to be able to identify the properties of those and kind of work in some other rules that go along with it. So the first one is going to be a trapezoid. And I'll zoom in so hopefully you can see it just a smidge better. In a trapezoid, I've got two parallel lines. So the two bases are going to be parallel to each other. And then the legs are just going to come up from one side to the top. It does not really matter what those angles are for a regular trapezoid. All right, in a regular trapezoid, all these angles can be different. It's just that I have two parallel sides and then two other legs. All right, on to the one that's we're going to spend kind of the most amount of time focusing on is going to be the isosceles trapezoid. I will draw the picture of it just to kind of simplify things down. So the first one is just a regular trapezoid. This next one is an isosceles trapezoid. So I'll go about to here so I can draw that picture on the side, hopefully. So I've got the top, I've got the bottom. Again, my drawing skills are not the greatest, but you get the idea. Okay, if I have an isosceles trapezoid, similar to kind of some of the other the other ones we had, this length and this length will be exactly the same. I'm going to use some highlighter rules again. This angle and this angle will be exactly the same. This angle and this angle will be exactly the same. And the very last rule that'll go along with isosceles trapezoids is that each one of these diagonal lines going all the way through, those ones will be the exact same length as well. So this entire diagonal line here and here will be the exact same length. Don't worry about all the theorem rules. We're not doing proofs still. The biggest thing I want you to see is that each one of these angles will be the exact same. These are the same. These lengths are the same. And these lengths are the same. Anybody need more time with that picture? Yes, good? Okay. So using that rule that we had, I'll give you a chance to draw the picture if you'd like to, and then I'll explain the whole thing. All right, so I've got the shape. I'm going to plot these numbers on the shape itself. Understand that this one is an isosceles trapezoid. So the first one, angle JML, that is this angle right here. That angle is 130 degrees. KN, the length of this line segment is 6.7 feet. So from here to here, that's 6.7. Let me get a different color pen so I can show this last part. MN, this line segment to here is 3.6. Okay. Because of that, it gives us all the information that we need. So this angle is going to be 130, based on that picture I had before. This angle over here will be 130. Okay. This whole entire line segment is going to equal this whole entire line segment. So if I look for this one to start with, angle MJK. Let me get that color. This one wanted me to find MJK. They want me to find that angle right up there. Using some highlighters because it lets me draw some things quicker. This angle and this angle are the same. This angle and this angle, I do not know. How many sides are in a trapezoid? 4 sides. Yep. I get 4 sides in that trapezoid. So I've got 4 sides. I've got 4 angles. Okay. So that tells me that in a 4-sided figure, the total amount of sides is going to equal 360 degrees. Right? I know one of my angles is 130. Actually, 2 of my angles are going to be 130. So I've got these ones down here are both 130. My 2 does not look like a 2. Let me make that better. Plus, I've got 2 more angles. Do I know what those top angles are yet? No. So I can give it a variable if I'd like. Okay. I'll just call it an x. So I know that all those angles added together are going to add up to equal 360. So this first part, I'm going to distribute it out. 2 times 130 equals 260. Plus 2 times x is going to be 2x equals 360. I want to get the x's on the side by myself or by itself. So minus 260 to both sides. I get 2x equals 100. Now I need to get x all by itself. Divide both sides by 2. My x value is going to equal 50. So with these numbers here that we went through, that tells me that these two top angles are going to equal 50 degrees. So for angle MJK, that'll be 50 degrees. Okay. On to that next one, it says the length of JL. JL is this whole entire length across. Anybody got some ideas on how I can solve that one? Perfect, Danny. Yeah. I got 3.6 plus 6.7 to get that one. So JL is the full length. So I'll take 3.6 plus 6.7. That's going to give me 10.3 for that total length. Perfect. Make sense? Anybody need more time? Sorry. Okay. Same thing. This one's a cafeteria tray. To save space, ours aren't like this, but some places have them, where they're going to have a trapezoid cafeteria tray. Okay, where they're going to be kind of slotted that way so you can slide them into the trays or into the washing machine a little bit easier. It says if WXYZ, this whole shape, is an isosceles trapezoid. So remember, isosceles trapezoid, that means that this angle, let me get my reds out there. That means this angle and this one, they're parallel to each other. This length and this length will be the exact same. And then the length of that segment and that segment will be the exact same as well. It tells me the angle YZW. So this angle right down here is 45 degrees. WV, this line segment, is 15 centimeters. And VY is 10 centimeters. Can you guys see those numbers on top of the blue? Okay. All right, from there we should be able to get all those different answers. All right, so I'm going to start looking at that. First part, it's got XWZ. So X is here, W is here, Z is here. So I'm looking at this angle. How many degrees would that one be? I'll highlight again if needed. 45. There you go, we got it, perfect. That one's going to be 45 degrees. Because this angle here and this angle are the exact same. So they're both 45. On to part B. It says WXY. So WXY, this angle up here. I need to figure that part out. Just like that sample problem we did before. How do I set it up and how do I solve it? 2 times 45. Perfect. Plus 2 times extra. Whatever variable, yep. Awesome. So Andy's saying that all four of these angles are going to add up to 360. I know the bottom two are 45 degrees each, which is where that came from. And I know the other two angles are going to be unknown. Now that we have it set up, it looks just like a regular algebra problem. Okay, 2 times 45 is 90. Again, if I'm going too fast for this part, let me know. But the algebra stuff, you guys crush it on. So I'm not going to spend a ton of my time going over that. So I got 2x equals 270. Divide both sides by 2. That gives me x equals 135. So those angles up top will be 135 degrees. Okay, and then xz is going straight across the entire thing. Xe, so I'll add up just like the ones before. I got 15 plus 10. That one's going to be 25. The last one, xv. Remember, it's going to be exactly like that one. Somebody said it, it's going to be 10. Isosceles triangles, or isosceles trapezoids, how you feeling? Good? Awesome. I'm not doing that. Okay, this last one that I'm going to show you does not have to be an isosceles trapezoid. It needs to be just kind of a mid segment of a trapezoid. Mr. Frable. Yep. Okay. Thank you. Bye. Josh, you're leaving?
Yeah.
Did you write down the assignment?
No.
You want to write that down when you head out? All right. On this rule, sorry about that. This rule here is if I have a trapezoid, every single line is going to be parallel. So I've got this length up here. I'll call it side A. This one's going to be B. And I'll say this is my midpoint. What I'm going to do to solve this, and that's kind of what this shape is saying, is I'm going to add these two together and divide it by 2 to find out the length of this one. Because it's going to be that trapezoid, really what I'm doing is I'm finding the average of that middle section. So I have the top one, I have the bottom one, and I divide it by 2 to get the midsection. That's what this formula is saying without trying to get all those extra letters and line segments. So it'd be side A plus side B all of that divided by 2, and that's going to equal the midpoint. Or the middle line segment. Okay, and that's saying that it's perfectly in the middle. That's what these little lines are saying. It's exactly in the middle based on those side segments. All right, I'll give you a chance to write those letters down or numbers down. With that formula. All right, so using this rule that I had before, okay, it is the mid segment of the trapezoid. It's trying to figure out what the value of x is. I know that the top one, this one, plus this one, so 20 plus the x divided by 2 is going to equal the midpoint. So it's going to equal this middle number, 30. So I've got this line plus this line divided by 2 is going to equal that. All right, I'm just going straight through and it turns into algebra again. So if this is dividing by 2, the opposite is to multiply by 2. So I get 20 plus x equals 60, because I multiply both sides by 2. And then minus 20 to both sides, x equals 40. Did that make sense how I got the average, or no? Okay. If you guys feel good about that, I'm going to just talk about kites. Very last shape we have. A kite is defined. Oops, I'll give you the name for that. A kite is defined by having the exact same 2 bottom measures and the exact same 2 top measures. All right, along with that, again, don't worry about the theorems that go into it. But the lines that bisect it, they are going to have 90-degree corners where both of those come together. So it's going to be perpendicular where those 2 lines come together in a kite. And then I'm going to go back to highlighting my angles rule. This whole entire angle and this whole entire angle are going to be the exact same length. So these 2 angles will be the exact same. Because it's getting bisected, this little angle and this little angle will be the same. And then this angle and this angle will be the same as well. All right, those are the rules that kind of go into the kites themselves. I'm gonna go on and do like 2 sample problems, and you guys will be on your way. Sorry, did anybody need more time drawing that picture? I apologize. Okay, so looking at this shape here, I got this kite. WXYZ, it's a kite. They want me to find XYZ. So they want me to find this angle down here. I don't know it yet, but I do know this angle because it's opposite of this. So it's angle ZB.
121.
Perfect. This one's 121. And now I've got a four-sided figure. I've got three angles. I can get the rest of it. I know that 73 plus 121 plus 121 plus, I'll say y, because that's the angle I need. All those added together will equal 360 degrees. Add the things that I know together. That's 242 plus 73 plus y equals 360. 360. This is 315 plus y equals 360 minus 315 to both sides. 315 to both sides. I get y equals 45 degrees. Is that making sense? Again, once you kind of figure out those shapes, you are set. This last one, I already drew the letters on, but I'll show you again. It's a kite. It wants us to find NP. Again, it gives us this length. This is this length here, and then these two are going to be the exact same length as well. To find that missing side, what theorem are we going to use? Pythagorean theorem. Awesome, Pythagorean theorem. I've got that same triangle. Look like 6 on this side, 8 on the bottom. This is the side we don't know. So it's a squared plus b squared equals c squared. 6 squared plus 8 squared equals c squared. We don't know what that is. Sorry. 36 plus 64 equals c squared. 100 equals c squared. To get the side all by itself, it'd be c equals square root of 100 or c equals 10. Anybody need more time with that one? Okay. Very last one. You guys are going to do it on your own. I just want to make sure you guys have it. I'll write the numbers in so you can see it a little bit easier. But here's the things they want. I want to find ADC and I want to find CD. So I'll write the angles in for you. All right, I'm gonna give you 45 more seconds, and I'll work through it. All right, if you're still working it, that's fine. I'm going to work through the angle one first. Just gonna make some little marks to show you which ones are the angles. So a reminder to figure that first part out. I need to add all of these angles together. So I have 38 plus 50 degrees plus, I'm gonna do this green angle plus another green angle. I'm just giving it colors as opposed to a letter. So green angle plus the green angle, all of that is gonna equal 360 degrees. So this would be 88 plus 2 of the green angles equals 360. Subtract 88 from that side. I get 2 times the green angle equals 272. Get the numbers right. Divide both sides by 2. That last angle is going to equal 136 degrees. So that green angle that we did from up there, that one equals 136. So angle ADC, 136 degrees. All right, as for the other two, it said find CD. I'm going to jump straight over there. That's another one of those right angles. This side was 5. This side was 8. The hypotenuse, the side C, we didn't know. So I'm going to do a squared plus b squared equals c squared. So I got 5 squared plus 8 squared equals c squared. 25 plus 64 equals c squared. That gives me 89 equals c squared. So my answer is going to be the square root of 89. Okay, the assignment for tonight. I shortened that down from what's actually on there. The stuff you guys will have is going to be page 444, 6 through 11, 16 through 21. You'll have a couple the first part will be all the isosceles trapezoids. And the second half is going to be mainly the kites. But that'll be due on Wednesday, with the review coming up on Wednesday within the test, kind of a shortened test-ish. Trying to get that done before the end of the week so you don't have to do anything over your 3-day weekend. Okay.